What's up, everybody? So we're back with another quick video. Last episode made this aluminum prototype for gearbox. Just to give you an idea, here is the 3D printed version, and I've since got a new set of gears. So this is the rf006 worm gear set that I use in the tank that Mike designed for worm gear set. So two parts, this part, that part, snap together. We have two of these inside the tank. So this is just a real quick one. Lots of stringing and stuff. I don't care. I just wanted to take some measurements off this. This is not actually going to go into use. So as we look at this, we have basically got a bearing that drops in there, sits down inside. We don't need that right now. And then circle gear, bearing, and that pops into that side there. And the little spacer goes in here to help pull up the slack. Right in here, there's like a little bit of play that can get introduced in there. So the motor gears all attach here. Worm gear, turns, spins the gear. This shaft right here is just what came with it, so I'm just using that for demonstration. On the actual tank, you've got something like this, which is a 6mm shaft. I'm going to take this over to the lathe and just cut, about 100mm or so off of that. So eventually we'll use that. So that's what it looks like inside. This joint right here of gear to worm gets hot. I was feeling heat up here. As I start to look at it, it's clear there's going to be heat that runs all the way around. There'll probably be heat that gets transferred down into there. And then this is pretty thin, I guess, so it'd probably come around here, maybe go sideways across the distance of the worm. So the idea, reduce heat, so forth. So last video, we saw this guy using just square profile end mills, did like a 3D machining profile on that. Can absolutely get this stuff to kind of fit in there, right? Gear drops right in. Worm pretty much fits. So was able to reverse engineer Mike's design, good enough for prototyping. This will snap on once all of that's rounded out. That'll snap on a lot better. So at the end of the last video, I showed an HDPE cutting board, and I was actually able to machine that with the ball nose mill I was talking about. So with a round profile, was able to get the contour I wanted. This is pretty much just throwaway material. I'm gonna focus in there. But not bad for like 5 minutes worth of work. Can now measure, tweak my design, throw this away, not feel bad about it, not tear through bits. So then we load in our gears. Come down just a little bit. My bearing popped out the back a little. Bearing and worm stack pops into there. So originally when I designed it, I just kind of looked in Fusion 360, looked for the gears to line up. They're a little bit tight. Went back through my email, got the proper dimensions from Mike of the center to center of the shafts, and basically moved this journal for that whole assembly back just a little bit from where I have it. We take the 3D printed cover, snap it right on there, and we start to see something that, it falls apart in my hand. Okay, we start to see something that starts to look like it's going to fit together a lot better, right? We start to now see that that's all going to line up when we get the measurements right. So I've gone ahead, made some adjustments to my Fusion 360 sketches, affecting the sketches, then affects the model, and affecting change in the model then affects all of the cam and machining operations. So I believe I've got, a small handful more of these to make. One thing that I talked about in the last video, I'm going to have to machine off this back edge, right? So as I look at this, these are pretty much the same height right now. So there's two things I can do. I can either try to flip this and repeat the carving and detail and stuff that's on here. So basically do the same profile operation, but from the other side and flipped over. That's possible. As Mike kind of indicated to me, I'm going to want to make a fixture, do my hole drilling on this side, pop it down onto some pins on the fixture so it doesn't move around, have the machine come back and do that cutting. So that's one option. Another option that I think I can do, if I were to look at this almost like a raft of a 3D print, right now I'm using a 1-inch HDPE. If I were to take that up to, I don't know, this is about 1/4 of an inch. So if I actually went up to 1 1/4 inches, assuming this is, I believe this is about 0.9 inches or something like that. So if this whole entire thing were now able to fit within the machine surface, I could just go ahead and cut the back off. And then as I look at the back of this, there's like 4 holes on there. I can go bang those out on the drill press like way quicker than I can do a second mill setup, touch off the center of this hole to get the alignment and positioning correct, go spot drill the holes, and then I still have to take it back to the drill press probably anyway to clear out the holes, unless I want to do another tool change on the mill. So I think there's a lot of machining time if I want to try to flip it over and machine the backside. So the easy way, probably machine the entire height out of the block. So I'm going to need to get a thicker block and then just cut all of that waste straight off. So it's just a facing operation at that point. So that's my quick status update about the motor project. Pretty excited now that, I don't have to tear through all this aluminum just to see if a gear fits in it, right? So that's pretty great. Next time I come back, I hope to have gone through a few of these, maybe even be on to the lid. I probably should have started with this piece. It's a lot thinner. I could have done all of that like within this piece. I could have already solutioned this. This part's a little more complicated though. So 6 holes, but 2 of them are actually for nuts. So I don't know. I could get in there, I could machine that out so a nut tucks in there and everything. Looking at the tank, I don't know if I really need that. It looks a little cosmetic. I definitely understand on a 3D printed part, how it sort of helps hold together, things like that. A better solution for me, might be just to thread the entire back hole there, leave that all solid, just drop, I guess it's a 6mm or something like that. Just thread that hole and then screw in through that side and just let that be, the surface it amounts to. All right, cool guys. Thanks for checking it out. We got all this wonderful stuff now. We don't have to take the tank apart to continue on this project. So the tank is going great. We'll flip over there real quick. So everything's, looking top notch. Just working on the software a little bit. All of the SLAM for the LiDAR is totally working. The last part is really trying to tie together the 3D SLAM for the Asus XGen camera. I'm trying to use RGBD SLAM, which is our ROS package. It's just having a lot of problems compiling. There's a few other packages involved, iGen, OpenCV, and G2O is the one I'm having a problem with right now. So once I can get that to compile, I think I'll be okay. But if that doesn't work, I think there's another one out there called Orb Slam. So I'm going to try that one out next. Alright guys, thanks for checking out the video. Make sure you subscribe to the channel and click the like button, leave us a comment. Peace.